You write a JavaScript function, it runs, it finishes its job, and its memory is wiped completely clean like a goldfish, right? Wrong. In JavaScript, some functions have an incredible memory. They hold onto their past. They remember the environment they were born in long after that environment has been destroyed. I'm talking about closures. It's the topic that strikes fear into the hearts of junior devs and dominates technical interviews. But today, we are going to demystify it. By the end of this video, you won't just understand closures, you'll be using them to write cleaner, bug-free code. This is part 1 of our closure series, where we talk about how functions capture their environments. Grab a coffee, open up your code editor, and let's dive in. Okay, to understand closures, you need to understand one basic rule of JavaScript. Functions can be returned from other functions. When an inner function is born inside an outer function, it gets access to all the local variables of that outer parent. It's called lexical scoping. But here is where the magic happens. What if the outer function finishes running, completely packs up and goes away, but it leaves the inner function behind? When that inner function leaves home, it takes a little invisible backpack with it. And inside that backpack are all the variables from its parent that it might need later. It doesn't matter that the parent function is dead and gone from the call stack. The inner function kept a copy of the house keys. That is a closure. It's a function bundled together with its lexical environment. Let's look at this in action. I'm going to write a function called prepare snacks. Okay, here I write a simple function, prepare snack, which takes a parameter snack type, and inside the body, let's declare a variable quantity, which is initially 0, and here is our inner function. So this prepare snack function returns another function, and here I'm going to increment this quantity variable from outside this function. So this variable is defined inside the outer function, and I'm incrementing it inside the inner function. And finally, I'm going to log a string. So using template literals, I can log u8 quantity and then snack type. Let's also add just here, just 8, a number, and then the snack type. Okay, cool. I save this. Notice what's happening here. Prepare snacks is taking in a snack type, and it has a local variable called quantity set to 0. Then it doesn't return a value, it returns a whole other function. Inside this return function, we are using quantity and snack type, both of which belong to the parent. Outside this function, I declare a constant eat pizza and assign prepare snack function, passing slice of pizza as the argument, and then I save it. Right now, prepare snacks has run. It is done. It is off the call stack. It has left the chat. By all normal rules of programming, snack type and quantity should be deleted from memory. But eat pizza is now holding onto that inner function. And remember our backpack analogy? Let's see what happens when we invoke it. Since this eat pizza is a function, I can call this function. So I save it and let's see the result. I go to the console tab. And here you see the result. You just ate one slice of pizza. Now what happens if I call this function multiple times? So I copy this and paste it. I save that and boom, look at that. It remembers. Every time we call it pizza, it remembers the string slice of pizza, and it remembers the exact state of the quantity variable, incrementing it each time. The closer kept that data alive in its invisible backpack. Just to prove how powerful this is, what if we call prepare snacks again, but this time we want tacos? Now, if we want tacos, we can simply add another variable, eat tacos. Again, assign prepare snack to that. This time, I'm going to pass taco or tacos. Then, here, I call eat tacos, and right after that, I call eat pizza one more time. I say that. Look at this. Eat tacos gets its own completely separate backpack. Eating a taco doesn't affect your pizza count. They each capture their own unique, independent environment when they were created. And that, my friends, is the core of closures. A function that remembers the variables from the place where it was born, no matter where it gets executed later. Now you might be thinking, okay, that's cool and all, but when am I actually going to use this in the real world? Excellent question. Closures are the secret sauce behind data privacy in JavaScript, creating factory functions, and even managing state in modern UI frameworks. And we are going to build some real-world, highly useful examples of that in part 2 of this series. So if this video helped closures finally click for you, do me a huge favor. Hit that like button to feed the YouTube algorithm its daily snacks. And subscribe so you don't miss part 2. Until next time, keep coding, keep learning, and as always, stay awesome.